Hey guys, today we are doing section 2A.5. It is the last section of notes for chapter 2A. We're going to talk about writing algebraic expressions. Really what we're talking about is writing algebraic expressions to represent real-world amounts. Now that is really the purpose of math, is that you can take things that are happening in the real world and translate them into a math problem to allow you to solve for different things. So today we start trying to take algebraic expressions and represent real-world amounts using them. I guess I wrote many, if not all, real-world situations can be modeled using mathematical equations. And often we will want to be able to represent real-world values using an algebraic expression. In this section we look at very basic algebraic expressions. We're going to be looking at expressions using a single variable. Later in the year we will talk about representing different amounts using different variables, but today we need to use the same variable throughout the whole problem. So the way you do this is you first let a variable represent some unknown amount. However, some problems have more than one unknown amount. So you let your variable represent the first unknown amount. And then you use that same variable in an expression to represent other unknown amounts. Here's the important part. Based on how it compares to the first amount. You'll see what I mean by that. We're just going to do some examples. All right, so this first one I think you'll find really easy. It says Kelly has X dollars in her purse. Write an expression for each below. So in this problem, we are just practicing writing an expression for other amounts based on how they compare to a known amount. The known amount is that Kelly has X dollars. We're going to write expressions for other people based on how they compare to Kelly. Now, part A says Jimmy has $5 more than Kelly. Well, what expression would represent Jimmy's amount of money? Let's see. $5 more than Kelly. Well, if Kelly has X dollars, like I was told, and Jimmy has 5 more than her, then Jimmy would have X plus $5. X plus 5 would be the expression that represents Jimmy's amount of money. It says that Julie has twice as much money as Kelly. Do we know what the word twice means? Well, let's see. I again know that Kelly has X number of dollars. If Julie has twice as much, it means I need to take Kelly's amount of money and multiply it by 2. Julie would have 2X dollars. And last up, we want an expression that represents the amount of money that Kelly, Jimmy, and Julie have all together. So what that is telling me is, it's telling me I want to add their amounts together. I want Kelly's money plus Jimmy's money plus Julie's money. So I'm going to take each of their expressions and substitute them in. That would be X, that'd be Kelly's money. Jimmy's money would be X plus 5, and Julie's amount of money would be 2X. There is an expression that represents how much money they have all together. X plus 5 plus 2X. And if I was really good, and we are, I would simplify that by combining my like terms. This and this and this are all like terms. Remember, those x's have a invisible 1 in front of them. So 1x plus 1x plus 2x gives me 4x plus 5. There's how much money they have all together. All right, we get the idea? Here we go. Let's do some tougher ones. It says the length of a rectangular play area is 10 feet less than twice its width. This problem has two unknowns in it. Do you know what they are? The two unknowns in this problem are the length and the width. So now I've got a decision to make. I'm always going to have x represent one of the unknowns. How do I decide which one I should let x equal? Should it equal the length or should it equal the width? Well, here's how I do it. It says in this problem that the length is 10 feet less than twice the width. They are doing some mathematical operations to the width to make it equal the length. So I'm going to want to let the width be my variable so that I can then do some mathematical operations to my variable to get it to equal the length. I hope that makes sense. So which one should we let a variable represent? I'm going to make that the width. Let x equal the width. I don't know why I wrote that twice. So then how would I calculate the length? Well, the length would be an expression which shows how it compares to the width. And it told me in the problem how it compares. 10 feet less than twice the width. I would start with twice the width. The length is twice the width, so 2 times x. But right, it's not twice the width, it's 10 feet less than twice the width. So the common mistake here again is to want to go 10 minus something. But that is not how you get 10 less than something. You get 10 less than something by starting with the something and subtracting 10 from it. Now, I have twice the width, but I'm subtracting 10, so I have 10 less than twice the width. 2x minus 10 would be our expression that represents the length. This brings me to my last two examples. Number 3 is a tricky one. Together, Sam and Diane have $25. If Sam has X dollars, how could we represent the amount of money that Diane has? So over here, I'm writing Sam's amount of money equals X. How do I represent Diane's amount of money? If you want to challenge yourself, try stopping the video and figuring it out, then come back and see if you got it. All right, here's the way to think about this problem. Sam's money plus Diane's money equals $25. That's what they told me in the problem. And I know that Sam has X dollars. So X plus whatever Diane has adds up to $25. And another way to think about that is to move the X to the other side of the problem. Diane would have $25 minus whatever amount Sam has already used up. This is the expression that would represent Diane's amount of money, 25 minus X. Anytime you have two numbers that add up to something and you know what they add up to, this is how you could represent them. One of them would be X, and the other would be the total amount minus what was already used, minus X. All right, last up, I don't think this one's that hard. It talks about some people bringing in cookies for a bake sale. Jake brings in cookies. Sally brings in 3 times as many cookies as Jake. That's important. And Mrs. Jones brings in 5 cookies less than Jake. That's important. Represent how many cookies each person brought in. So first I'm going to want to write down the 3 people. Now the question is, which of these 3 people should I just use x for, my single variable? And again, I would point out that Sally is compared to Jake, and Mrs. Jones is compared to Jake, so it makes sense if I made Jake the person who brought in X cookies. And if Jake brought in X cookies, now I can just look at the other 2 and see how they compare to X. Sally brought in 3 times as many. So 3 times X would be 3X. And Mrs. Jones brought in 5 cookies less than Jake. Okay, to get 5 cookies less than Jake, I start with Jake's amount of cookies and subtract 5. So Mrs. Jones brought in X minus 5 cookies. And I am done. Hope that helps. Good luck.